Welcome to Khetz Tutorials, and in this video we're going to talk about the unit circle. Before we talk about what it is and how to use it, let's do some revision. So remember that sine of theta is the opposite over the hypotenuse, which is the same as y over r, right? So if you're dealing with a Cartesian plane like this, you have the x-axis and you also have the y, and r will be the longest side or the radius in terms of a circle. So from there to there, that'll be r. Now cosine theta would be x over r, which is the same as the adjacent over the longest side, which is also the hypotenuse, right? Finally, tan of some angle theta would be y over x. Now keep this and remember this. We're going to use it in a while. As part of our revision, or if you did not know, 1 pi radian is equivalent to 180 degrees. So we usually express angles in degrees, but when you're dealing with calculus or any other international standard, we usually represent our angles in pi radians. So this is the conversion which we're going to use. Finally, I wanted to talk about reflection. So if you reflect coordinates about x, you're going to negate the y. And if you reflect about y, you're going to negate the x. And here's what I mean by that. So the first example, if we had coordinates 1, 2, and we reflected these about the x, we negate the y. So the reflection about x would lead to us negating the y. The y in this case is 2, so it'd have 1 minus 2. That would be the reflection of this coordinate. And reflecting the same point about y, so let's say reflection about y would lead us to negate the x, so it would be minus 1, 2. So the same coordinates, but we're going to apply each of these reflections. So with this information, we're now ready to go on to the unit circle. So the unit circle, as the name suggests, is a circle with a radius of 1. So as you can see, I have this as the center, so this is 0, 0 on a Cartesian plane, and I have a radius of 1. Now, going back to the trig ratios, we can now use all of that information which I just talked about to use this unit circle. The unit circle is used to quickly find values such as sine of 30 degrees. So you can come here directly to the unit circle and find what this is. So this is how you'd use this circle to find what this value is or any other value on the unit circle. So before we do that, let's talk about the angles on the unit circle. So the first point here corresponds to 30 degrees. The next one is 45 degrees. Next one is 60 degrees, 90 degrees, and so on. But instead of representing these as angles in degrees, let us focus on the radian. So you can do the conversion. Just remember 1 pi radian is 180 degrees. So I'm just going to help you or to show you how you construct or how you plot these angles around the circle. So you're going to start with pi over 6, which is 30 degrees. Skip 1. So now let's count. Here's an easy way to remember how to construct these. Let's count in pi over 6. So you're going to start here at 0. So this is 0, obviously. And first one's pi over 6. Skip 1. Go to the next one. 2 pi over 6, which can be simplified to pi over 3. Then go to the next point, which is here. And here you're going to have 3 pi over 6. So we're just adding 1 to the numerator. So 3 pi over 6 there, which is the same as pi over 2. 180 divided by 2, which is 90 degrees. So here we have 90 degrees. Then you're going to continue like that. So this is 3. Then here you're going to have 4 pi over 6, which can also be simplified as 2 pi over 3. So this is the same as 2 pi over 3. I'm going to skip 1, go to the next one. So we add 4, now we add 5 here. 5 pi over 6. Then here we have 6 pi over 6. 6 pi over 6, the same as pi. which is 180 degrees. So from there to there, you have 180 degrees, so that checks out. Next, this was 6. Here, we're going to have 7 pi over 6. Skip 1. Next one, 8 pi over 6, which can be simplified to 4 pi over 3. Okay. Then the next one would be 9 pi over 6, which can be simplified to 3 pi over 2. If you work this out, this is 270 degrees. So that was a 9. Next, we're going to go to 10. 10 pi over 6 is 5 pi over 3. And we're going to skip 1, go to the next one. We now have 11 pi over 6 there. And finally, we're going to have 12 pi over 6, which is the same as 2 pi, which is the exact same point where we started at 0. So if you go full circle, you have 2 pi, which is 2 times 118, that's 360. So that's a full circle. Now, these are the angles which we added just by counting in pi over 6, but we skipped a few. So the ones which we skipped are actually quarters. So now, the first quarter which we skipped is pi over 4. Then the next one, here at this point, we have 2 pi over 4, which should be pi over 2, which we already have. Then we're going to come to this point where we have 3 pi over 4. So this point here is 3 pi over 4. And this point is 4 pi over 4, which is the same as the pi, which you already have. Then the next one which is skipped, which is this point here, after 4 pi over 4, we have 5 pi over 4 at that point. So this here is 5 pi over 4. Then at this point, this is 6 pi over 4, which can be simplified to what we already have, 3 pi over 2. Next one which we skipped was this one here. And this was 6, so the next one will be 7. So this point here, we have 7 pi over 4. Finally, we have 8 pi over 4 here, which is the same as 2 pi. So we're now done with the circle, and we've filled in all of the angles which are around the circle. I'll now quickly show you how to get these coordinates. When I started the video, you just saw them on the diagram. Didn't really explain how they got there. Well, luckily for you, you just have to worry about these numbers. And the numbers are 0, a half, square root of 2 over 2, square root of 3 over 2, and 1. So these are all the numbers which you have to remember. And now I'll teach you how to place them. Starting here at 0, you're going to now have 1, 0 as your coordinates. So these are your starting coordinates. And this makes sense, as you'll see in the next section when I show you how to use these coordinates. So you're going to start at 0, 1, 0, and decrease the x while you increase the y. And this only applies now, or at least in this situation, the first quadrant. So if you decrease 1, then we're going to go to the left using these numbers. So if I decrease it, it will now be square root of 3 over 2. And as you can see, the next one is indeed square root of 3 over 2. And if I decrease it some more, then I'll have square root of 2 over 2. That is what I have for the next angle. Next angle, I'm going to decrease again, and I'll have a half. And finally, I'll have 0 here at cosine of pi over 2. So that is how you go about it in the first quadrant. And as I said, for y, you're basically going to increase your values. So starting at 0, you're going to go in the opposite direction. So starting at 0, now I have a half, square root of 2 over 2, square root of 3 over 2, and finally 1. That is exactly what we have. 0 at the starting point, a half, square root of 2 over 2, square root of 3 over 2, and finally sine of pi over 2, or at pi over 2, we have 1. And that is how you construct the first quadrant. Now I might be asking, how do you translate this to the second quadrant? And that is where the reflection which we talked about comes in. So if I reflect at this point about the y-axis, now I'm going to negate the x. That is why this is negative for half, and that is positive. So this is the exact same coordinate that I have here, but it has now been negated because there was a reflection about the y. The same applies to all of these other coordinates. So this is the negative x of this due to the reflection which occurred. So moving from the first quadrant to the second quadrant, you basically use a reflection about the y-axis. And next, from the second quadrant to the third, you're going to use a reflection about the x. And if you do that, this has been reflected to this, which means we're going to negate the y. This positive a half is now negative a half. That stays the same, that stays the same. And the same applies to all these other ones. They have been reflected about the x. Finally, the fourth quadrant, these coordinates have now been reflected about the y. So this now negates the x again. A negative x will now become a positive x, and so on. The same applies to all these other ones. So all of these have been reflected to this side about the y, and that is how we got those coordinates. So as you can see, you only have to remember these numbers. You only have to remember the direction in which you go. So x decreases in the first quadrant and y increases. And once you have this quadrant, you're basically going to reflect, reflect, and reflect, and you have the full circle. And as you work these out, you'd see that we haven't really talked about these ones, but they will make sense when we get to the next section when I teach you how to use this unit circle. Now we can use this. So remember, we said sine, for example, was y over r, and we said that the radius of this circle is 1. So that's the r, so this is the same as y. And cosine is x over r. If the r is 1, then it's just x. Finally, tan remains the same because this is y over x. So if we're looking for sine of 30 degrees, which is sine of pi over 6, we're going to come to the coordinates which are at that point and look for the y coordinates, and that is a half. And just like that, we have a value. So this is how you use the unit circle. You're going to go to the angle which you're looking for, and the y coordinate gives you the sine value of that angle, and the x coordinate gives you the cosine of that value. And at any point, let's say tan of 45, which would be pi over 4, we can divide y by x. So in this case, these two are the same. So if we take them from that point, and it gives us 1. And you can check this with your calculator as well. So this is how you use your radian circle. I taught you how to construct it, how to fill in the angles, and how to use it. And that will be based on these trig ratios and their simplification. And now, if you're asked for an angle which is not on this, you can basically continue counting. Remember that we ended at 2 pi, and you can still add each of these values or find multiples of these, and they should lead you to some point which is on the unit circle. So this is extendable, or you can extend this to multiples of these angles which are on the circle, or if you can just continue counting, adding on to the angles which you already have, and you're basically going to end up with the angle you're looking for. So I hope this was useful. You can now construct the unit circle. You can now associate angles with each point and use it to find actual values. So that is all in this video. I'll see you in the next video.